Welcome to this video on adding and subtracting polynomials. By the end of this video, you should be able to add polynomials by combining like terms, and you should be able to subtract polynomials by distributing the negative sign and then combining like terms. So let's try some notes to see what I mean by those two I can statements. One thing you have to remember, as we've already talked about this, is combining like terms. A like term means the variable and its exponent are exactly the same on the two terms that we're trying to combine. Our exponent rules tell us if we are adding or subtracting, do not change exponents. So I'm just going to make a note here. If we add or subtract, do not change exponents. Okay? We will change exponents when we multiply and divide, which we'll be doing next. Okay, so adding polynomials. That is the easiest one. When there's an addition sign between two polynomial expressions, all that means is go ahead and find terms that are exactly alike and combine them together, follow their sign. Here's what I mean. We have a single x term. It's 11 with a single x. So I'm going to look all the way through and see if I have another single x term right here, negative 5x. Those are like terms. I can go ahead and combine them. 11x minus 5x is 6x. Right? Let's try it again. The next term is a squared term. Okay? I'm going to look all the way through and see other squared terms. Here's one. And that's all there is. So I have, let's remember a 1, negative 1x squared plus 2x squared. That would equal a positive 1x squared. And the last thing I have here is I have a constant. It does not have a variable on it. I'm going to look through for another constant, which is right there. So I have 13 minus 23, which is negative 10. So now I need to look, is my answer in standard form? This exponent has a 1. That one has a 2. It needs to be the biggest exponent first. So it's the biggest exponent I've got is x squared. There's really a 1 there. The next biggest is 6x. And then minus 10 is my constant. So when I look at this, I have 2 exponents, 1 exponent, and this has no variable, so it has no exponents. That is my final answer. Okay, let's do a couple more additions before we look at the subtraction problems. So let's look at number 13. It's adding in between. That means we're just going to find like terms and combine them together. I have x. Look all the way through. There's another single x. Those are the only two. Remember, here's a 1. 1x plus 4x is 5x. And then I have a constant of 5. I'm going to look, and here's another constant of negative 7. 5 minus 7 is negative 2. I've used everything from the original problem, so I'm going to look, is this in standard form? I have 1 exponent, no exponents. That is my final answer. Let's try 15 right below this. Let's see, we start here. I always just start with what's right up front. We have a w cubed. I'm going to look through, are there any other w cubes? There are not. There's nothing to combine it with. That means it's just going to come down just the way it is. The next term is a squared term. Look all the way through for more squared terms. Those are the only two. So I have negative 2w squared plus 3w squared equals 1w squared. And then I have a constant of negative 5 and a constant of negative 11. Negative 5 minus 11 is negative 16. Check out your exponents to make sure we're in standard form. 3, 2, none. They don't have to, all of them don't have to be there, but they do have to be in order biggest to smallest. There's our final answer. All right. So addition, pretty straightforward, combine like terms. Subtraction, we have to remember to do one thing before we get started. When we have a subtraction sign between the two parentheses, it means this subtraction is applied to everything in the parenthesis that follows it. you have to distribute, because really what it's saying is there's a -1 right here that has to multiply to everything inside the parentheses after it. Okay, so nothing is happening to the first parenthesis, so I'm just going to copy it back down. 4x squared plus 5x. Then I have -1 times 7x becomes -7x. -1 times 3x squared becomes -3x squared. -1 times +1 is -1. Now that I've done that, I can go ahead and combine my like terms, but I want to point out, notice none of the numbers change because I'm multiplying by 1, but because it's a -1, their signs change. That was +7x, it became negative. +3x squared became -3x squared. +1 became -1. That's all that's changing is the sign in front of it. So let's take a look. I have an x squared term. I'm going to look all the way through for another x squared term right there. 4x squared minus 3x squared is 1x squared. I have a single x term. I'm going to look through. Here's another single x term. Those are the only two. 5x minus 7x is -2x. And then I have my constant out here on the end. That was the only thing left. Can't combine with anything, so you bring them down as is. -1. Check for standard form. 2 exponents, 1 exponent, no exponent. We are in standard form. All right, let's look at a couple more subtraction ones so we can get a little bit more practice in on them. So let's take a look at number 19. Okay, it has a subtraction in front of this parentheses. There's nothing in front of the front parentheses, so it's not going to change. X squared plus 17x. And this is a -1 that has to be distributed to the parentheses afterwards. That's a +3x, so it becomes -3x squared. +5x becomes -5x. Once you've distributed, then we can go ahead and combine our like terms. I have a squared term. Look for any other squared terms. Here's one. So remember, there's a 1 there. 1x squared minus 3x squared is -2x squared. I have a single x term right here. Look for any other single x terms. There's one. 17x minus 5x is a +12x. And there's nothing else to combine. We used everything from the original problem. So let's check our standard form. 2 exponents, 1 exponent. We are finished. That is our final answer there. Okay, let's try 22. I have a minus sign in between. That means I need to distribute the -1 to everything that comes in the parentheses after it. Nothing's happening to the first one. 3m squared plus 7m minus 1. Positive m squared becomes -m squared. Positive 2m becomes -2m. -5 becomes +5. Now let's check out what we can combine. I have an m squared. Keep looking until I find all the m squareds. I think those are the only two. So I have 3m squared minus 1m squared. It's going to be 2m squared. All right. I have a single m term. Look for any other single m term right here. All right. 7m minus 2m is a +5m. And then we have a constant, -1, and a constant, +5. -1 plus 5 is a +4. Check your standard form. 2 exponents, 1 exponent, no exponent. It's in largest to smallest. So it's standard. There's our final answer. Let's not forget how to add. Remember, adding we like because it's faster and easier. If you're adding, there's nothing you have to do but combine like terms. I have an a squared. Look for another a squared. There isn't one, so I just bring it down. 6a squared. Okay. Here I have just an a term. Look for any other just a terms right there. And, oh, look at that. I didn't even see him right there. So we need to combine all of those together. So I have -5a plus 1a is -4a minus 5a is negative 9a. And when I look, the only thing left is this, and that is a cubed. There are no other a cubes, so just bring it down, 3a cubed. Let's check for standard form. We have 2, 1, 3. The 3 is the biggest one, so it needs to be the one that goes first. That's a positive, so we don't have to write anything in front of it. 3a cubed. The next biggest is 6a squared, and then minus 9a. And that's our final answer. The last two that I want to do with you are right down here on the bottom, 25 and 26, because I didn't set them up for you. I gave you words to tell you what I wanted you to do. Find the sum of this and this. Sum means addition. So what it means is it wants you to take 8p squared minus 2p plus 15 plus 11 minus 2p squared minus 1. These two sentences say the same. One says it in math and one says it in words. We have addition in between. That means we can just combine like terms. So we have a p squared term there. Look for any other p squareds. Here we go. 8p squared minus 2p squared, 6p squared. I have a just p term, p to the first. There is no other p to the first. And that is minus 2p, so I'm going to say minus 2p. I'm just going to bring it down. Now I have a constant. I have a 15, I have an 11, and I also have a negative 1. All of those are like terms. They have to be combined together. 15 plus 11 is 26. Minus 1 is 25, so plus 25. Check for standard form. 2, 1, none. There we have it. That's our final answer. So 26 might get you. Pay attention to what it says. It says subtract this from this. So really what it's saying is this one minus this one. So we're going to write the second one first. W cubed plus 6w squared minus 2 minus 2w squared minus 5w plus 10. You have a minus sign in between. That means you got to distribute the negative 1 all the way through. Nothing happens at the front end. W cubed plus 6w squared minus 2. That's a positive 2w squared, so it becomes negative 2w squared. Negative 5w becomes positive 5w. Positive 10 becomes negative 10. Now we can look at our like terms. I have a w cubed. When I look all the way through, it's the only one, so I'll just bring them down. Okay? Then I have a w squared. Any other w squareds? Those are the only ones. So 6w squared minus 2w squared is a positive 4w squared. I have a w. Let's see. He doesn't have anybody who mixes with him, combines with him, so just bring him down, plus 5w. And I have some constants. I ran out of shapes, so I'm just going to underline them. Negative 2 and negative 10. Negative 2 minus 10 is negative 12. Check for standard form. 3, 2, 1, none. That is our final answer. So be real careful. If I'm telling you to subtract, the order is going to actually switch when you ask it in this form. All right, hopefully that answers your questions. See you in class.